So we're starting off the chapter on probability. We're talking about sample spaces and probability. So a probability experiment is an action or trial that has varying results. The possible results of a probability experiment are outcomes. Well, whenever you roll a six-sided die, there will be six possible outcomes. Maybe you get a 1, 2, 3, 4, 5, or 6. So those are your possible outcomes. That would be known as your sample space. That's the set of all possible outcomes. Now, an event would be one or more outcomes, such as rolling an odd number. In this case, the event would include 1, 3, or 5 if your event was to roll an odd number. So that'd be 3 favorable outcomes out of a total sample space of 6. Now we're going to see about making a sample space out of this situation. You flip a coin, so I already know that is going to either be heads or tails, and you roll a six-sided die. So it's either 1, 2, 3, 4, 5, or 6. How many possible outcomes are in the sample space? List the possible outcomes. So maybe you land a heads, and you get a 1. Maybe you land a heads, get a 2, and so forth. The other possible outcomes is maybe you got tails on the coin flip, and you would still have perhaps gotten a 1, 2, and so on. And these would be all your possible outcomes. Well, there are 12 of them. What we get on in the next lesson is that you can multiply here. 2 possible outcomes times 6 possible outcomes would be 12 possible outcomes. So a student taking a quiz randomly guesses the answers to 4 true-false questions. What's the probability of the student guessing exactly 2 correct answers? Actually, I'm not caring about what's true and what's false on this quiz. I'm caring, since I'm talking about them getting correct answers, I'm going to use C to represent a correct response and I to represent incorrect response, not T and F here. So now we're going to list all possible combinations. So maybe the student got all 4 correct. Maybe the student got the first one correct, second one correct, third one correct, fourth one incorrect. And now you're just going to start making all your possibilities show up here. And there's different ways to think through this. I really kind of leave it up to you on what you might be doing in order to comprehend what's going on here. So it takes just a little bit to actually run through the gamut and actually show what could have happened. And I'm getting pretty close here to actually having finished the correct side. 1, 2, 3, 4, 5, 6, 7, 8. So this is all the possibilities on if the student got the first one correct. Then I'd list them all for this, getting the first one incorrect. I'm going to just do that real fast. Really easy to make a mistake through all of this. Alright, now that I've done all that, I have 16 possible outcomes in total. What's the probability of the student guessing exactly 2 correct answers? So what I'm now going to do is just quickly say, alright, 2 correct answers, exactly 2 correct answers. That happens here, 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 and then here, here, and that looks like it. There should have been more, so I made a mistake somewhere. Oh, there it is, here. Okay, so that's 6 favorable outcomes where the student got exactly 2 correct answers on this quiz. And so that would reduce to 3 out of 8. You can also answer with percent if you would like to, because 3 out of 8 would represent 37.5%. So experimental probability is based on actually performing trials of the event. So instead of just assuming that, for instance, if you toss a coin and land heads or tails, you would know that the probability of getting heads should be theoretically 50%, and that getting tails would be 50%. Experimental probability would be the fact of I'm going to actually flip this coin maybe 100 times and record how many times I actually get heads. If I get heads 45 times out of the 100, the experimental probability of getting heads would have been 45%. So it's actually carrying out the event multiple times and recording the data. So in example 3, each section of the spinner has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So for any color, since all the colors have the same area, the theoretical probability would actually be 1 out of 4, because there's a 1/4 chance you land on this color or this color or this color or this color for any of the colors. Over here, they've actually performed the event and actually recorded data to actually take a look at it. So the probability of landing on red is 5 times out of 20 total. You'll notice that these also add to 20 right here. The probability of green is 9 times out of the 20. So it was much more likely to happen than 1/4 of the time. For the probability of blue and the probability of yellow were both 3 out of 20. Sorry that ran off the screen there. Now, of those, red would actually reduce to 1/4 or 25%. So the color that has the same probability is red. So on this problem, you really have to read all the way through carefully to know what your actual denominator is going to be. It gets impacted by the problem. In the United States, a survey of 2,184 adults, so you might think that that's your denominator. It's actually a trick. Ages 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? This is known as a condition. So I'm not looking at all adults surveyed. I'm only looking at the pet owners, which is 1,328 of them. At that time, now I'm going to look for my favorable outcomes. By the way, if you're a curious student, you might notice that these add up to be greater than 1,328. Well, that would show the overlap, the people who have more than one pet. All right, so what's the probability that if you're in this group of pet owners that you have a dog? That would be represented by the 916 on this histogram. So 916. Now I can simply just type it into my calculator, is what I'm doing off to the background here, and getting 0.6897, or that would be 69.0%. Usually you're going to be expected to round to the nearest 1/10 of a percent in this chapter. That'll be good enough for what we're doing in this class. All right, thank you for watching.